that, okay, a competition is out 2 a.m. that get up and I see the data set, I make a notebook on it. It was like mostly probably the first or second training notebook. LoRa cannot be any better now. It cannot produce any better results. We have reached the limit of how good LoRa can be. In the beginning, I was getting a lot of feedbacks on writing, thinking about all the edge cases.
So, Tanay, welcome to the show. Thanks so much for taking the time off. Could you start by just telling us about yourself, like how you got started into data science, machine learning, and all that?
Right. So thanks a lot for inviting me. So I started my data science journey, and this is back in 2018 when I started my undergrad in India in computer science and engineering. So it was during COVID when I got really interested in Kaggle because I was interested in data science for a long time, but
Hmm.
during COVID I had a lot of free time, and I started using Kaggle, and it was a very gamified process in the sense that you could put something out in whatever category, the competition or a notebook, and you get votes from people or you get medals. And that sort of struck the right nerve. And so I decided doing more of that. But before that, I learned, so I taught myself machine learning and programming using, I don't remember exactly, but it was an MIT course on
Hmm.
YouTube that teaches basic Python. I think it's Python Fundamentals course. And then I learned machine learning using the gold standard, the Andrew Ng's course for
Yeah,
machine learning that
yeah.
I don't think it's unfortunately there anymore. But yeah, those courses. So then I started doing Kaggle, and I learned a lot from Kaggle. I basically learned all of PyTorch just from Kaggle. No other courses, no nothing.
Fantastic.
Just looking at notebooks, uh, taking part in competitions, and yeah. So after that, it was in November, I think 2021, when I got an internship at NVIDIA India as an applied research intern in machine learning. So that's when my career really started sort of, boosting towards this direction. So after my internship, I got really involved in open source machine learning, and that's what I've been doing sort of ever since,
Hmm.
contributing to open source machine learning projects and also doing Kaggle here and there.
Yeah,
So
yeah.
yeah, that's basically been.
So you are a Kaggle Notebooks Grand Master. So what does it even mean? Like, how did you get into such a specialized Grand Master space?
So on Kaggle, there are four tiers: notebooks, datasets, discussions, and competitions.
Yeah.
Obviously, all of those four tiers have their progression system. So all four of them have expert, novice, master, and grandmaster. Different requirements, obviously. So for competitions, I believe in order to become a grandmaster, you need one gold medal and like one solo gold medal.
Hmm.
So two gold medals, which
Hmm.
is like people take years. So some people have taken like 6, 7, 10 years to get that because solo gold medals are like super hard.
Yeah.
Notebooks, I believe, is like the second hardest in the sense that you need, uh, if I'm not wrong, you need 20 gold medals and a total of like 50 silver plus medals. So for reference, one gold medal is 50 votes on a notebook, 50
Okay.
or plus unique non-novice votes, and a silver medal is, I believe, 20 or so non unique non-novice votes.
Yeah.
So when I started Kaggle, I really liked. At first, I was doing a lot of data analysis and data science, like EDA and basic machine learning, because that's what I knew by that point.
Hmm.
So I started making a lot of notebooks on the excellent data sets that are on Kaggle,
Yeah.
and that I then slowly getting the kick. So I got out of my comfort zone, and then I started going in competitions. So I used to set up my reminder and alarm. There was this really nice Twitter account that would send you a notification every time a competition was released. And so even in the middle of the night, you would get a notification in India that, okay, a competition is out 2 a.m. that get up, and I see the data set. I make a notebook on it. It was like mostly probably the first or second training notebook.
Okay.
And yeah, so that's basically how it sort of went, because it gamified me to such an extent that I just wanted to be the first one to put out a training notebook every
Okay.
time.
Yeah. And that becomes the basis on which everybody else sort of builds their model, and then you
Yeah.
start getting upwards because it's really useful for them. Yeah, I get
Yeah.
you. So did you get started in Kaggle like before even the notebooks style of submissions came in, or when you started, it was all just notebooks already?
When I started, I think the 4 tiers were there. So notebooks, competitions, discussions, and
Okay,
data sets, they
okay,
were all
yeah,
there.
yeah, okay, yeah, that's fine, that's fine. So what's your favorite like Kaggle competition so far? Like, which one did you really enjoy doing?
There was one when I was just starting. It's 2020, I believe.
Hmm.
And the competition was mRNA COVID vaccine
Oh yeah,
detection, something I don't remember anymore. And
yeah,
it
yeah,
was
yeah.
such a nice competition because it's tabular. And
Hmm.
I think you had to predict the mRNA structures
Hmm.
using any sort of RNN and LSTM, some basic transformer models.
Okay,
And I really like that one. I didn't get medal in that one. I got medal in other competitions, but that was the one that like really captured. That's what really got me excited in competitions in the first place.
okay, okay. That was kind of like an initial playground with which you learned about like how you go about. So that also triggers the question of like how do you go about like cracking these competitions? So let's say one competition is launched, and then like you have the data set, you have all those instructions, like, and then people start writing in the community, a lot of comments and all that. But so how do you go about navigating all this?
So I'm obviously no expert in competitions per se, but I think from the previous competitions that me and my team have done well in,
Sure.
the basic approach is to use like our basic sort of skeleton structure that we follow is
Yeah.
use an existing notebook, like a training notebook or a training sort of baseline that people have put out and build from there because there is no need to reinvent the wheel every single time
Yeah.
writing your I mean unless you have encountered something similar before, it makes sense to write your own scripts because you clearly know what have previous experience in. But otherwise I usually start by taking a really good baseline
Okay.
on the Kaggle notebooks part, and I take it and I improve upon it. So mostly if it's, let's say we are just talking about a simple image classification
Sure.
competition,
Yeah.
the ones that used to be a lot common back in the day.
Yeah.
So I think taking that baseline, extending it, adding more features like gradient accumulation during training and Apex support for PyTorch training and so on and so forth. And then once I have a really, really good baseline established that I know I can't really improve upon it anymore, without turning it very differently, without sort of changing it too much, then I start doing ensembling. I start using
Okay.
multiple models and a combination of
Yeah.
models.
Yeah.
So the way I've done and the way me and my different teams have done it throughout these competitions was that going step by step
Mhm.
and then revisiting a step when you have perfected at some point and okay, now we can go back and tune very minor, very simple things in
Yeah.
the process until we know what's right. And I would like to point out that the discussions forums in the Kaggle competitions, they are
Yeah.
very helpful
Yeah.
because people share their learnings, people share external data sets, especially these days, because there are a lot of LLM related competitions and the data sets externally on like Hugging Face data sets and so are like very helpful. So the discussions forums have helped me a lot. Like
Okay.
I cannot, I cannot state how much they have helped me in understanding these competitions and getting good results in them.
Okay. Yeah, you said like you need to go step by step to sort of improve the model. So can we jump slightly into deeper into it, like to understand like what sort of parameters you tune, like what steps do you take to improve the model? Let's say you're doing a
Sure.
classification model or a model of your choice, LLM model or whatever.
Okay, so if we take, for example, an LLM model for instance, and we are fine tuning a large language model. So in that case, let's for the sake of argument, let's stick with a smaller model
Yeah.
that we can fine tune easily. So the first step would be to take a pre-trained model like Llama 3 7 billion one, for
Yeah.
example, and we try the LoRa and all these lightweight training methods
Sure.
that are not too intensive and it can be done on very low hardware. For example, the one that Kaggle provides, I think the best hardware they provide is like two T4 GPUs
Hmm.
or one P100 GPUs, either one at one point. So you take that and you do LoRa on the data set. and you tune it very well, you choose the rank very well. And once you're satisfied that, okay, LoRa cannot be any better now, it cannot produce any better results. We have reached the limit of how good LoRa can be on our data set.
Yeah.
Then you sort of move up and you do parameter efficient fine tuning. You move up from LoRa and you do more compute expensive fine tuning,
Yeah.
and you go ahead. So obviously in all these small stages there are their own parameters to fit. So in parameter efficient fine tuning you choose what sort of precision level you want to go for, because that affects the performance. In LoRa, on the other hand, you choose what rank you want to take, or and these sorts of parameters. So and once you're like satisfied, okay, and you have a lot of compute, let's say, the DGX gods are a little considerate on you, and you have a few A100s here and there. So then you decide, okay, maybe I need to do proper full fine tuning, and I have the resources for it. So then you go full fine tuning, or you just make your own data set, you construct it, and then you tune the proper model completely on it without any, quantization or any sort of tricks for
Okay.
compute saving.
Okay. Yeah, that makes sense. But this is all to do with the model, right? So the model parameters, be it BEFT or whatever. So before you even like touch the model, like how much time do you spend with the data, like pre-processing, understanding the data? Like, so can you walk us through that process?
Yeah, definitely. So I think that's the place where I spend a lot of time on.
Okay.
I would, because the data really determines the sort of, not just the type of model you should be using, but also the type of technique you should be training it on. So, for instance, I mean, EDA, I think, is the most important part. And my approach is that I never take an EDA notebook on a competition. Like, they're excellent ones. I cannot do justice in my sentence of how good they are on Kaggle. But I think EDA is something that everyone should do by themselves, with their own hands, because that's what teaches them about the data more than, seeing someone else's charts and graphs. So I like to do EDA myself,
Okay.
dig deep into the data, see if it's like, for example, a tabular numerical data, I want to see the distribution, see if it's
Mhm.
skewed or not.
Mhm.
If it's classification, see how much imbalanced it is, and all that. And also see, for example, if you're talking about images, I also like to see if there is any leak in test set and train set to, or test set, train set and validation set, I'm sorry, to see if, the integrity is consistent, that do I need to do something. So for instance, there was this competition, there was a Shopee product competition. I think it was
Yeah.
product identification. I
Mhm.
remember it was 2021. And if I may be wrong, but they had some products that would duplicate in train set and val set or test set. And
Okay.
so, and I think someone identified it in the discussions. So then I went on GitHub and I found this image deduplication library and I ran it on the data set. And after
Okay.
that, my model performance significantly improved.
Okay.
So that's something you only find out with EDA. Let's say you did basic EDA, not too in depth, and you just straight jump to the modeling. There's no way you could see that coming. And you would think, okay, maybe the models are just, this is the performance.
Yeah, so when you do EDA with on like images and stuff, like, so do you just normally visualize images, or like do you do some sort of a PCA or a TSNE to visualize, or what sort of visualization approaches do you take?
So with images, and it's been some time since I dabbled in a vision competition, but I really like to do I visualize individual images, and if the data set is small, like in a few gigabytes, in order of a few gigabytes, I try to download it, and I see individual images, like not all of them, but I like to see as much images as I can to get an idea of how exactly the data set is and the
Okay.
classes,
Yeah.
because a lot of times it can tell you a lot about the data set that you just don't see in a plt.plot,
Hmm.
so to speak.
True.
So
Yeah.
so see the images, and if the data is higher dimensional, yeah, definitely, then I like to do PCA and TSNE to see how exactly is the data structured, how it's distributed, to get a better grasp of the techniques that would come in handy.
Okay. Yeah, that makes sense. Uh, and so when you're like playing around with models, like when you're fitting the models, so is there any sort of like uh, s- these days, like, is there any specific models that you can think of whenever you say, like, when you want to do LLM, like, is there any favorite or something of preference for you when you want to fine tune or whatever?
So in terms of LLMs, I think really depends on the task, but for code-related tasks, my go-to model is the Hugging Face Big Code's Star Coder, which is a
Okay.
really powerful model, as well as the Code Llama 7 billion one. So Code Llama 2, I don't think Llama 3 has a code version out yet,
Okay.
but yeah, so Code Llama 2 7 billion one is small enough to be done inference on, I think, two GPUs or a single GPU, and you can fine tune it properly on like two high memory GPUs. When it comes to like models that like smaller parameter size models, I like to work with the Mamba model family because that's something that I really like. It's not a transformer model family. It doesn't
Yeah.
use
Yeah.
attention, and it has really great it has really great performance. I have fine-tuned it to some extent to do code generation tasks, code infilling tasks. So yeah, I for smaller models to experiment, I really like to work with the Mamba family in like 1 billion parameter range. uh, in the more if I'm doing more of like natural language text generation, not code generation, I think the basic Llama 3 7 billion one that's like very recently released is pretty good, as well as the Gemma 7 billion one is also
Yeah.
pretty good by Google.
Yeah.
So I really like those one too, especially the Gemma 7 billion because I like its performance on a lot of text generation tasks.
Okay.
It's actually pretty good.
Yeah.
It exceeds expectations for me personally.
Okay, that's interesting. And you also brought up Mamba, like he's about the hype, like it's all the, it got rejected in ICLR and all that. So what's your experience with Mamba? Is it really better than Transformers?
I think like I have worked with the Mamba. I'm not sure exact parameter number, but the 1 billion one, the closer to the 1 billion parameter one, I think
Okay.
it's 1.4. I'm not sure. 1.4 billion parameter model. I have personally found its performance really good for a 1 billion parameter model because let's be honest, like you could make an image classification model with 1 billion parameters that
Yeah.
big enough for that. So for natural language generation and for text generation, 1 billion parameter language model is like it's pretty excellent for the size. um I also released this training repository where you could train it to do code generation tasks because I was trying to make, and it's still an ongoing effort when I'm trying to
Mm-hmm.
make a small VS Code-esque extension
Mm-hmm.
that uses a small Mamba that is fine-tuned on code infilling
Mm-hmm.
using fill in the middle code infilling. So far my experience has been pretty good, and training it hasn't been very tricky.
Okay.
I won't put my feet on down on if it's like better than Transformers, but I think it's something worth thinking about, away from
Okay.
Transformers.
So given that it's different from a transformer model, like what about the parameters? Like, is it similar parameters that you want to deal with, like in Mamba, or how is it?
So in Mamba, when it comes to, I'm not even sure if I think I haven't explored it if LoRa is something that can be done with Mamba. I'm
Okay.
pretty sure there's a smarter way to do it, but given uh, given its small size, I think it's very practical to actually just go and fine tune it properly
Okay. Okay.
without any parameter efficient tuning. That's one of the reasons why whatever experiments are going on with Mamba are a thing because it's so small. You could actually just fine tune it on a consumer level, like one RTX 3090, 24 gig. You could just fine tune it properly
Okay. That's
without a
nice.
problem.
Yeah. That sounds more practical. Yeah.
So it just becomes like another LLM fine tuning. You just change the context length a little. You changed a few parameters, learning rate, and you get a good data set. Sometimes synthetic data sets are really good in getting the good performance. However, I'm not sure about how good they are downstream. So like the tiny stories data set is uh, is a pretty good. I think it's like 1 or 2 years old now,
Hmm.
but that data set has shown that it converges large language models very well
Okay.
later on, and not converges, but like it gives very nice performance even on just a basic transformer model for text generation.
Okay. Okay. Yeah. Makes sense. Okay. Let's slightly move on to a different topic. Like you said, like you learned the entire PyTorch all on Kaggle actually. So how do you go about that basically? I thought like, I would have thought about like going through the docs and like, just the implementing stuff and
So I before that, so the first framework I learned was TensorFlow back in 2018 when we used to create like session graphs and do ses.run to run the computations.
okay.
And so I kind of had a low level idea because of during that time, Keras was something completely different from TensorFlow. They were
Yeah.
not really one thing as they are now. And so I kind of had some low level idea on like on how the specifics of like machine learning engineering as I like to call it work when you're actually training a model. So when I went on to Kaggle and I saw a lot of notebooks just using PyTorch, I realized that okay, maybe it's more preferred than TensorFlow, which it came out to be eventually.
Yeah.
So I would just see the notebook. So my best approach was if let's say it was a deep learning competition, right? It was basically, let's say, a text classification competition. I would go to the notebooks. I would see the most. I would sort by the highly rated notebooks, and highly rated means the ones that got the most votes and all that. I would go to the notebook that got the most votes, the training notebook that got the most votes,
Okay.
and I'd start from there. So my approach in the earlier days was that I didn't know PyTorch, and I was impatient enough to go to the docs or see a tutorial or a playlist of how
Okay.
it works. So I just took a pen and paper and a notebook and I started writing down things instead of relating it to what it means in TensorFlow 1. And slowly it started making sense. So I just basically took the code and I didn't copy it in my own like notebook. I tried to write the similar functionality a little differently.
Okay.
And it sounds very small, but when you do it enough times, like even for 3 or 4 competitions, you kind of grasp the internal because you run into a lot of errors. And coming from a different framework, it's you approach things with a little different mindset. And when you run into errors, you just search on them. I think that's like the best way to learn
Yeah.
a framework personally.
Definitely. Yeah.
And eventually you do run into docs. I mean, it's not like I never saw the docs. Eventually you do have to see the docs. But not in a sense that you just open the docs for the first time. Oh my God, what is this?
Okay, yeah, makes sense. And how do you get, but like, using these notebooks and stuff is quite recent. Like, it's all triggered by the data science community. Uh, you know, Prior to that, like, I used to be a Java developer and like we used to use IDE all the time. And then even when I started with Python, it was all like IDE, PyCharm and everything. And then, VS Code came in and like everyone's doing VS Code now. It's all like notebooks. So you as a notebook expert, like, are there any tips that you want to give about like how we can work on these notebooks? In general, like
Um, I'm personally like I used to be a very deep notebook fan back in the day because
okay.
Kaggle basically the most preferred way of using Kaggle is using notebooks. You could use scripts too. You can execute scripts, but slowly as I'm more into proper engineering, so machine learning engineering job, I'm kind of more inclined towards scripts. However, the notebooks, there's one thing that most people don't know about is that if you write a notebook in a certain sequential manner, like you don't jumble up the cells, you write it in a manner that if you restart the kernel, run it from top to bottom, it runs exactly perfectly fine. You
Mhm.
can run it in terminal using a command called ipython3. So it will execute like a script. So that's like a small tip that I use. When I don't want to convert it to a Python file, like I
Okay.
do something, there's a training job, for example, small training job. Obviously, bigger training jobs are supposed to be run on scripts. That's the best way in from
Yeah.
a development perspective. But for small training jobs or benchmarks, you just write it in a notebook, and once you're sure that the code is correct, it's not going to give an error. Just go to the terminal and run it in a screen in Ubuntu or something,
Mhm.
and just get out, and it will do its job.
Okay.
Um, Other than that, I think notebooks are, and I know it's been said a lot of times before out there, but I think notebooks are really good uh, when it comes to like demoing things, seeing if they work or not, doing the sanity check.
Yeah.
But still, I would really prefer scripts. And if not scripts, then I would really prefer the ipython3 command, which executes them like a script from top to bottom.
Okay.
So yeah.
So, people. Is there a way to structure all this? Like, as in, like, I normally see the imports at the top, and then like I see some functions in the middle. Suddenly, people are writing like a couple of commands. Like, I always feel this notebooks are like a little bit messed up. So, are there any tips
Yeah.
on like structuring these?
Oh, I absolutely get my blood pressure raised a few points when I see an import 3 cells down from the main import
Exactly.
cell. So I think all the imports, even with the try catch blocks, let's say you're checking for certain system hardware compatibility for an import, I think personally that's my very radical belief. It should be in the first cell. After the, and I mean, if you're executing a notebook, not on a Kaggle, but like on your local environment, I don't think the pip install command should be there at any point in the notebook, because if you are on your local environment, once you've done pip install, it's one time
Yeah.
thing, right? It's always going to stay in your environment. On Kaggle, it makes sense because
Hmm.
if you're installing something that's not in Kaggle Docker environment, you kind of need to install it every time you fork the notebook or restart it. But yeah, so imports at the top, I think configuration and other related, definitions where you load the parameters. So my sort of signature style that I develop for training notebooks is that installs in the first cell, that's hidden, imports in the second cell always, other than markdowns. I'm not counting markdown cells here. Third cell would almost always be tracking tools like warn B. For example, if I want to track my training run, so a warn B instance and the configuration. So all these hyperparameters like batch size, learning rate, number of layers, and all that, they should be like in the third cell in a class or a dictionary. And then after that, I start defining all these individual classes. And the main training cell that runs everything, that runs a training loop, for instance, that comes at the very last cell.
Okay.
So that's my kind of go-to structure that I always follow.
Yeah, that makes total sense actually. So, okay, and you've also given some talks about like best practices for PyTorch and all that. So, what are your tips for what are your? Can you give us the gist of the talk basically? Like, how do we go about dealing with PyTorch?
Yeah, so I think there are like a lot of small things in PyTorch. So for instance, it's like a very small example, right?
Sure. Yeah.
So let's say you have a, I don't know, text classification example, and you're using GPUs or a single GPU, let's say for simplicity, and you have a data loader. So if you put pin memory equals true, your data loading will be much faster because it will. I think what it does is that it before you transferring your data to GPU, it manually transfers it automatically transfers it to the GPU, or it does something that makes it much faster.
Okay.
So, and for example, when you do zero grad, so optimize it or zero grad to clear out the gradients for the next step, if you do set to none equals true, it will be, I think, a little bit faster because
Okay.
it sets the gradients to none instead of zero. So these are like very small things that I included in that talk.
Hmm.
I believe it was in Kaggle Days NCR 3 years ago, I think. And it was like a bunch of all these small little optimizations that when you do them all together, it boosts up your training a lot. So one of them was when you calculate loss, so or any
Hmm.
tensor that's on a GPU and you call the dot item function, it transfers it to the host. It transfers it to your CPU memory. And if you do that again and again, because the transfer takes time, and the transfer basically like stops all the process, it transfers it, or you print something that's a tensor that's on a GPU. It's a costly process. So you should do this once and you save it as a temporary variable. So whenever you're printing it or logging it to won't be, for instance, you're not doing it again and again, the same transfer that's redundant.
Yeah.
So these are like very small, like they're not proper model level optimizations. They are the small coding level optimizations, implementational level
Yeah.
that can
True.
boost. Because when people talk about optimizations, they are like straight jumping into the model
No.
and pruning and quantization. But a lot of times just fixing your code in your training loop does the trick. Not does the trick, but it boosts the performance a lot.
Yeah. So you're a big open source contributor. So let's walk us through like what sort of repositories that you've contributed to.
So I started my contribution with HuggingFace Transformers. That's where I still have a pull request work in progress, and I'm still contributing. I also contributed to Lightning AI, a few small fixes, and
Yeah.
DeepMind's Optax, which is I was really big in JAX back in the day, like an year or so ago. So I added a couple loss functions to DeepMind's Optax, which is basically like the optimization framework for JAX-based neural networks.
Yeah. Okay. Yeah, I think you're the right person to ask this question then. So how do you compare and contrast all three of them basically? I always wanted to especially figure out the difference between or the how Lightning AI performs against like Hugging Face Transformers.
So HuggingFace Transformers really is it's a framework that integrates with Lightning AI and JAX and Flax and PyTorch and all other ones because it's really a repository of NLP models and vision models as well.
Okay.
So it allows you to sort of fine tune them, train them, do inference on them very easily. So that's what Hugging Face Transformers is all about. Lightning AI is more of a framework built on top of PyTorch. So it extends PyTorch to ease into the developer workflow, and it allows you to train models really easily on multiple GPUs, even on TPUs, with not going through the usual trouble of in stock PyTorch. You have to basically use DDP, you have to use a distributed data parallel or fully sharded data parallel, depending on the setup you're going for. In PyTorch Lightning, it's pretty easy. You can just it's not that hard, and it's a very streamlined workflow. DeepMind Optax, DeepMind Optax is basically a framework that provides all the loss functions for JAX and Flax-based neural networks.
Okay. So have you directly contributed to JAX or Flax, or is it just Optics?
Actually, I am currently working on a small PR for JAX, like core JAX itself,
Fantastic.
basically
Yeah.
extending the JAX.image functionality. But I think that's my personal belief that JAX source code takes some time to understand, even
Okay.
not completely, but to some extent to do the contribution. That is not to say that other source codes are like not complex. They are in their own right, and they're doing excellent work.
Yeah.
But I have previous experience, so I kind of got the hang of it. Like in Transformers, when I see an error, I kind of, in most cases, know exactly the script it's coming from.
Yeah.
So you get that point. You get when you work with the code base for so long, you kind of get a hang of something of that.
Yeah, true, true. You're familiar with the other
Yeah.
packages within the modules within the code. Okay. And yeah, do you think JAX will catch up with PyTorch, or what's your opinion on
Oh,
that?
definitely. I think it's only a matter of time. I
It's a
think
matter
it's
of time.
because a lot of things that you do in PyTorch that, for example, let's say TPUs, right?
Yeah.
They're still a big thing, and they're getting only better with time. I think for TPUs, if for using the like using TPUs in PyTorch. I'm not sure what the current developments are, but from what I last know, you have a third external package called Torch XLA or like TPU XLA. I'm not sure what the name is,
Mhm.
and that would allow you to use TPUs with PyTorch. JAX has built-in support, and its support is not that different from like the API itself is not very different when you use GPUs, multi-GPUs versus TPUs.
Okay.
And the built-in support for JAX that allows you to do distributed training and all that. In PyTorch, you would be better off using something like I'm not sure, Microsoft DeepSpeed. Yes, that's the name. So for distributed training in JAX, you really don't need that. It has excellent sharding like capabilities of its own and all for all sorts of tasks. So JAX has more, I would like to say, the better support for distributed training and so on.
Okay.
It's it still hurts me a little that Jack there are very few JAX models out there. Like
Yeah.
there are now in the recent couple of months, but still comparatively less than PyTorch, and that's I think something that's um, I believe personally that that's a little limiting factor in JAX popularity is the limited option of models to train and fine tune.
Yeah.
Because if you want to attract a lot of newbies who just want to who want to learn the framework, the best way, for example, I told you about my experience. I learned by fine tuning models on
Yeah.
Kaggle.
Yeah.
The best way for someone else, some other person to learn JAX is by fine tuning models, and there are some of them, but not as many as PyTorch.
Okay. And talking of switching between the two, then, like, are there any tools or like packages available to sort of convert models from one to another?
I think there must be, but I think Hugging Face has it has a utility file because I briefly worked with it,
Mhm.
where you give in a PyTorch model and it converts it into I believe a JAX model frozen dict, the JAX corresponding version of model. Um, Otherwise, it's actually not that difficult if you understand the model architecture. So when I contributed to HuggingFace Transformers, I kind of did something, but for a different thing. So my first contribution was this model called Pool Former,
Mhm.
which was the first non-attention based, I think. Yeah, I believe, I'm not entirely sure, but it's basically like Vision Transformer or Seg Former, but without attention. And they showed really great performance that you can achieve using a transformer architecture, but without using attention. It
Okay.
also created a bit of controversy back in the day because they claimed a few things and all that. But ultimately, coming to that, so that was my first contribution. And what that required was the model was initially trained. It was an image model. It was trained, and the model, the weights were saved in the TIM format, Torch Image Models format. And
Yeah.
when you have to implement that to PyTorch, to Hugging Face, you have to write the model architecture in a specific format that conforms to what Hugging Face framework has, the specific way of implementing an attention class and multi-headed attention class and so on. So when you do that, your model architecture is a little different than the original one. So we have to always write a script that convert the original weights to the new weights. And in PyTorch, it's rather easy because it's a dictionary. So you just, at the end of the day, a PyTorch model is just an ordered dictionary of keys and values. So you change the key names and you load the models in. So I think fundamentally, JAX converting PyTorch models to JAX models shouldn't be that hard.
Mhm.
It should be definitely hard than converting a model from one PyTorch framework to another one because they are all tensors. But I think with a little bit of deep knowledge of the model itself, it should be very easy. But again, I would like to emphasize that I believe Hugging Face has a utility for that. I do not remember the name right now from the back of my head, but they definitely do have one that automatically converts PyTorch weights to JAX Flax weights.
Nice, nice. Yeah. Okay. And talking of this open source contributions, like how do you set up your system? Like, do you set up your VS Code for open source contribution in a specific way? Or are there any plugins and stuff that you use for improving your productivity or?
So I think so. So whenever I start by whenever I want to contribute to a new repository, the best place I think to start is their contributing file. So they have a contributing.md page,
Sure.
mostly on their docs or on their GitHub, where you go and they have certain things that you should install. So for example, Hugging Face has this thing called Black, which is a formatter which they use.
Hmm.
So
Yeah.
one thing that I would really recommend to everyone who is doing open source, especially to a repository that allows Black formatting, is that there is an extension for Black on VS Code Marketplace. So you install it, and there's a setting where you can basically do format on save. So every time you do Control S or Command S, it automatically formats your file.
Okay.
And I have been using it for so long, even for my personal projects, that all my code from the last 1.5 year on GitHub is so beautifully formatted, and it's like following the PEP 8 guidance and
Wow.
everything. So yeah, so that's one of the things. I think other than that, there was another extension called Git Lens, which gives you more perspective on the Git, how Git works, or like the Git history, essentially, the
Hmm.
commit history of that specific file which you're working on, or of all the files. But I think it really depends mostly on the repository. And a word of caution to anyone who's starting their first like open source contribution, please start with a fresh environment
Okay.
and just install the frameworks or install the things necessary provided by the repository, recommended by the repository, because a lot of times old extensions from other repositories that don't follow the same rules here in the new framework, they cause a lot of problems, and I have had to close so many requests. And yeah, so that's my advice, to start anew with a new fresh environment. That helps a lot.
Okay, that makes total sense actually. Yeah, and also I believe like you learn a lot by contributing obviously to open source repositories because you get these code review feedbacks and you improve your coding skills along the way as you sort of get these feedbacks. So can you sort of summarize the sort of feedback that you got? Usually it comes down to a few points and then you get a hang of like you become a basically senior person who can review others' code. So what sort of feedback do you get, like what for improving production code?
So I think in the beginning I was getting a lot of feedbacks on writing, thinking about all the edge cases. And
Yeah.
I think that's what lead code also teaches you in some extent, is
Mm-hmm.
thinking about all the edge cases. I think on GitHub it's more deep than lead code is, because it's not one problem. It's you have to think on a multi-dimensional level based on how many files you're working on and how they integrate with each other.
Sure.
The other feedback is write good unit tests. That's like the best feedback I keep receiving on, because that's something I'm still getting a hang of it. But writing good unit tests really, it's a self measure of improving yourself, because if your unit tests are good, you need not worry about the actual feature that you're implementing, because your unit tests will ensure that they are correct.
Yeah.
So writing good unit tests and having really good coding practices help, because if you make small like let go of small things, small problems in your code, like one line is extending beyond the PEP 8 guideline. These things, they add up at some point.
Okay. Okay.
So there's also, I think, so Pylint offers you a way that rates your code out of 10. So you run Pylint on your code file, it rates your code out of 10. So that's a very nice way of,
Yeah.
it grounds you, it makes you write good code.
Yeah, I think that wasn't there before. Like probably they have introduced it recently, apart from Pylint.
Yeah.
Okay. And how many times does like the code go back and forth before your sort of your PR is merged?
I believe it depends on the feature as well as the repository itself. But I think with me, sometimes I have had 2 or so months of back and forth.
Okay.
Because it depend it has a lot to do with where your mind is at versus where the developers want you to be at. And I think it's a really, really wonderful process,
Yeah.
because they
Sure.
sort of gently nudge you in the right direction, and you learn so much. Like I believe I have learned more on like open source contributions in the last 2 years than I have learned in any of my undergrad computer science classes. I think, because it
Definitely.
teaches you a lot at the very core, like how to be a good software engineer. And what's really beautiful about that is you don't need to then prove to someone on your resume or CV. Like
Yeah.
I don't even half of the times put GitHub contribution. I just put the GitHub link, because it's all in public. Anyone on the internet can go and see the
Yeah.
whole back and forth and see a merged PR and see your code in the production. It speaks for itself. So I
Yeah.
think it's better than anything, like any sort of thing you can put out as a software engineer. An open source, a reasonably good open source contributions is better than everything, personally.
Okay. So for someone starting in data science and machine learning, so what was a sort of simple repository you suggest someone get started contributing today?
So if someone is really interested in the software engineering sort of part of machine learning, which I was in the beginning, I would say HuggingFace Transformers is still a really nice place to start,
Okay.
as well as Lightning AI. Specifically target the good first issues. So they
Okay.
have a label called good first issues specifically for beginners. You go there, you see a good first issue that's not been taken, you work on it, and don't be afraid to ask questions. Ask the more dumb questions you ask early on, the less dumb mistakes you make later on. That's my
Okay.
mantra.
Okay.
So ask a lot of bad questions. They mostly invite you to, you can join their Slack and all, which is
Okay.
much better, because there are sometimes very simple questions that just don't get in your head. You can ask them on Slack rather
Okay.
than on GitHub issues.
Yeah.
But I think it's still perfectly reasonable to ask them. Once you think you are doing the good first issues well, there are mostly good second issues and good hard issues.
Mm-hmm.
I believe they're called. So these are more harder issues, specifically in that order. And I believe once you complete that whole cycle of the beginner issues, then I think you can jump into bug fixes and all. So the key thing here to take away is the labels. Take good attention at the labels. Use the labels and sort the issues by least commented. So the least commented issues are mostly the ones that are not taken, or the
Okay.
ones that are like sort of forgotten about, that you can tackle on early. And after that, once you're confident, I think you can just see an issue and just open a PR to fix it. After talking, you like in a couple of issues, like in 5-10 fixed PRs, merged PRs, it becomes this sort of thing where you have gotten a hang of the whole
Okay.
repository.
Yeah. 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 And I missed this question early on. So you were talking about like unit tests and like we have to cover so much unit tests. So do you write the tests first, or like how do you go about, or do you like the functionality first? You know, it's a chicken and egg problem basically.
Yeah, so what I like to do is I like to write a simple draft, like a very basic version of functionality that from the looks of it does exactly what I wanted to implement, like nothing more, just the core functions that I wanted to implement. And then I write tests in depth, and then it's an iterative process in
Okay.
my own brain. So I extend some functionality, and then it's an immediate bulb sign in my brain. I have to go write a test for that. If it's
Okay.
something that can break the test, I must write a test for it.
Okay.
And you go back and forth until you have exhausted the points that you have to implement, and then you see if the tests are correct or not, because a lot of time tests need to be in the exact right format. But yeah, it's generally faster if you first implement core functionality and then write tests.
Okay. Okay. That makes sense. Yeah. Just form a skeleton and then like go back to testing and then like then it's back
Yeah.
and forth. Yeah, totally makes sense. Yeah. And so, what are your thoughts on the future of LLMs? So, you've been working on LLMs for a long time.
Yeah, well, I mean, that's one of my summer dissertation topics is basically training LLMs. So, it's the morning starts with training LLMs, the night ends with the seeing the logs. But I think I would personally like to point out that I may not be, I don't find myself 100%, the right person to answer this in depth. There are so many people with greater experience than me out there, but
Yeah,
I think the whole hype of LLMs taking over people and all that I think is quite unjustified because they, I personally think they can only be as good as the data they are trained on, which is
true.
what it is. I think we should focus more on data than model architectures. Of course, model architectures are important, but ever since I read the Chinchilla paper, I realized that paying attention to data is more important, much more important by a significantly larger margin than paying attention to the data. Most models, not most models, but a significant majority of models out there, LLMs are like undertrained because they haven't been trained on the data they should be trained on to
Okay.
saturate their performance.
Yeah.
Um, I think there is also a greater need of understanding the in context learning, which is something that my dissertation, my topic is all about, my research topic is all about, is understanding and hunting down the in context learning abilities. So Anthropic, I think, came up with the really influential paper about 2 years ago, which is about mechanistic interpretability. Basically, an LLM learning, quote unquote, without gradient updates of the model, like without actually doing gradient update. Model is learning from the context, and that's, I
Hmm.
think, something more research should be done. I personally chose this topic because I'm just so passionate about to see when LLMs actually start having this so-called phase transition in their
Hmm.
training stage.
Yeah. So,
So yeah.
as someone like who is still in the academic side, like, so how how do you balance your time between like reading papers and like being hands-on, like open source contribution and all that? So how do you keep up with the speed of the,
So
yeah.
yeah, so I think reading papers has now become a sort of a habit, like
Okay.
using LinkedIn or using Twitter, in
Okay.
the sense that it's hard to build. I'm not going to lie, it's very hard to build. But I used to work at this company where I was an NLP engineer about like 1.5 years ago, and they were the ones who kind of pushed me to it because what happened was it was a very NLP intensive. It was kind of a research engineer role, so I had to learn a lot of papers, and they made me learn like read like 13, 14 NLP papers, more prominent papers in a week. And once you do that, once you have this push, you get out of your comfort zone, you realize, okay,
Yeah.
it's not that hard. It's actually not that difficult.
Yeah.
I think there is a really nice video from Andrew Ang on YouTube that he explains how you read a paper, and you don't read it in one pass, you read it in multiple passes until you understand it. Like you first start by reading the beginning at the end, then you read a little more, and then you read a little more. And I can't do justice. You people should go and watch it. It's Andrew Ang, How to Read Papers. It's very simple, but that's a really nice way. I like
Okay.
to read papers. I print them out at the beginning of the week, and I read them and I highlight them with my highlighter. I don't like to read them on my iPad anymore. I just don't get the feel.
Yeah. Okay.
So about managing the academics and all, I think it kind of becomes one thing when you are doing the same thing. So when my the dissertation topic is also LLMs and my interest is also in LLMs, and I'm doing software engineering related to LLMs mostly, it kind of becomes one whole task rather than, okay, I have to do academics and I have to do open source. It coalesced into one task for me.
Okay. Okay.
So I wake up in the morning, I'm still doing the same thing at night. A little different, but same thing nonetheless.
Yeah. Makes sense. So it's all part of the journey, is what you mean.
Yeah, it's all, and it's just one big journey. It has become one big journey. Back in undergrad, it was much harder because I was doing multiple very different things from each other. But now it's just one big journey, and it's more interesting. So I think if someone is in their masters and they are yet to decide on the thesis topic, I would just recommend don't choose the easy one, choose the more interesting one, because you will only go far when you choose the interesting topic. An easy one, yes, but it won't lead to your personal growth, and that's all that matters personally.
Okay. So talking of more interesting ones, like, so what is the most happening sort of topics or areas of research happening at the moment in LLMs?
I think definitely the in context, understanding more about the in context learning,
Okay.
and as I said, the mechanistic interpretability, and seeing exactly what the model thinks internally. So I think Google released a tool very recently. It's very nice that you can actually see what the model reasons, not completely, but you can kind of get a grasp of how exactly the model thinks about things, and LLM. So that's one of the ways. I would really like more attention to be given on using less attention methods in LLMs, because so as I said, Mamba is one of them. That was a really nice paper. And the another recent paper that came out was Recurrent Gemma or Recurrent Gemini. I'm not entirely sure of the name, by Google, where they also showed, I think, a transformer-free architecture by Google. So Recurrent Gemma is another nice touch. I think more uh, research is being done or should be done on using less attention-based methods for large language models,
Okay.
because attention is quadratic in complexity,
Yeah.
and it scales quadratically with the sequence size. So it's not very scalable. Like you just need to throw more GPUs at a problem to solve it. That's
Yeah.
the way to go.
Yeah, yeah. So, do you think the field is also progressing towards that direction? Because given that now it's a few years back, like 8 GB GPU was a big thing, but now it's like you have all this huge GPUs, and then they're like having a cluster of 4 or 8 GPUs is normal. So, do you think we should go in that direction, or like should we focus more on efficient models on less compute?
I think definitely the latter. I think efficient models on less compute is a way to go, because right now I think Meta is the only big company with enough resources that are actually open sourcing their models, or not open sourcing but openly releasing their models.
Yeah,
Um, as much as I appreciate personally, and these are all my very personal opinions, but as much
sure.
as I personally appreciate their move towards this, I still think that uh, a more wider variety of efficient, high performant models that can be run on, even if not consumer grade GPUs, but on smaller GPU setups, it would be much better we would be better off with that than, larger and larger and huge models that only a few can run. Because realistically, let's say the Llama 3 400 billion model, which they claim this is still under training, if they do even release that, which I know they will, how many people will be able to actually, how many researchers will be able to run that
Yeah, yeah,
with limited budget? Even on LoRa, you can't, even on LoRa, you can't find, I mean, maybe you'll be able to fine tune that, but it's very hard. It's a 400 billion parameter model. You need like 8 GPUs or something to do
yeah,
inference, basic non-quantized inference on it. So I think the focus should be, and I'm personally trying to affect this change in myself, to focus more on smaller models, and that's what I'm doing. We are training
sure.
smaller and smaller models to see when the phase transition happens in smaller models, if at all.
Yeah.
To see maybe we are better off with smaller size models.
Yeah, that absolutely makes sense. And how is academia coping with this pressure to sort of build on more and more hardware, because the resources are limited compared to a big company like Facebook or Google. So how are people dealing with it in academic side?
I think it's definitely a problem. It also comes down to what sort of school you're talking about or what sort of university you're talking about. More bigger universities have actually access to bigger clusters. University thankfully also has its own cluster. Um, but I think the sheer size of models now, and I think it was reported by someone on Twitter the other day that it's just private companies, enterprises that are coming out with large models. It's not
Yeah.
academic institutions because they just don't have this much resources, and rightfully so. It's impractical to assume a university, a not-for-profit university at that, to have hundreds of thousands of H100s.
Yeah.
So that's why I think it's also much more needed, because I think that the large progress back in the day that led to where we are right now happened because a lot of people could train these models and research on them without, needing to spend thousands of dollars. And I think unless we are consumer grade, the researchers will be limited to large institutions and large companies only.
Yeah.
And yeah,
Yeah, I'm absolutely with you on that. Yeah, yeah, you share my opinion definitely on that. Yeah, on that note, yeah, thank you so much, Tanay, for being on the show. I really appreciate taking the time off, and like you gave some lot of tips for our audience. And yeah, thank you so much once again. And yeah, hope
thanks
to
a
see
lot for
you
having me.
sometime. Yeah,
Yeah,
yeah.
soon. It was a pleasure. Thanks a lot. Bye bye.
Bye.